Okay, and so we have the limit as theta approaches 0 of 1 minus cosine theta all over sine of 16 theta. Okay, so using our trig identity, cosine of x equals 1 minus 2 sine squared of x over 2, we can apply that identity here in this problem so that we can manipulate our expression into something that hopefully we'll be able to evaluate. So here we have 1 minus, and then cosine theta we sub in using our formula. So we have minus 1 plus 2 sine squared of theta all over 2 all over the sine of 16 theta. So the idea here is that we want to get the sine of 16 theta out of the denominator because that is creating a 0. And so we can eliminate that by multiplying by 16 theta all over 16 theta. And so now we have, using our theorem, the sine theta all over theta, that would give us 1. Okay, so that right there is just 1. And so these 1's cancel out in the numerator, and that brings us to 2 sine squared of theta all over 2 all over 16 theta. Okay, and we know that we have to keep going because, again, we would have a situation of 0 in the denominator. So in the numerator now, we can split the sine square theta over 2 into sine of theta over 2 times sine of theta over 2. And then that's all over 16 theta. Okay, and so continuing on, we can use the same technique that we used up here, right, to eliminate sine, to go about eliminating one of those signs in the numerator to see if that helps us out. So we can do that by multiplying by theta all over 2 all over theta all over 2. Again, I'm just multiplying by 1, so I'm not changing anything. And here, this quantity just gives me 1, right? And then a little bit more that we can do in the numerator here. We have our 2 here, and theta over 2 right here. So, well, actually, that's sine of theta over 2, and this theta over 2. There you go. We have all of that left. We have this 2 can divide with that 2 to make things a little easier, and this theta with that theta divides out, and so things are getting simple quick, right? So now we are left with the sine of theta over 2 all over 16. All right, and so now we're in good shape because we have a non-zero denominator, and we can just evaluate then the sine of 0 here, and we end up with 0 all over 16, which of course is just 0.